Imagine you're sitting at the very top of a roller coaster more than 100 meters above the ground. The train begins to move slowly, click, 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 until suddenly the track disappears beneath you. The train drops almost straight down. Your heart feels like it's left your body. Then, without warning, you race into a giant loop, completely upside down. For a moment, you're hanging high above the ground, yet somehow you don't fall. Seconds later, the train twists, turns, spins at speeds over 150 kilometers per hour. But here's the real mystery. Why doesn't the train fly off the track? How can hundreds of tons of steel stay perfectly locked to the rails, even while traveling upside down? What happens if the power suddenly fails? Do the brakes still work? And why do engineers trust these machines with millions of passengers every year? The answer isn't luck, it's one of the most incredible engineering systems ever created. A system designed to keep every wheel, every bolt, and every passenger exactly where they belong. Today, we are going behind the scenes of one of the world's most thrilling machines to discover how roller coasters stay on the track, how they survive extreme forces, and why they are far safer than most people imagine. This is the engineering behind roller coasters. At first, a roller coaster looks simple, just steel rails and a train, but hidden beneath every car is one of the smartest mechanical systems ever designed. Most people think the train simply sits on top of the track. It doesn't. In reality, every roller coaster grips the track from 3 different directions. The first wheels sit on top of the rail. These are called road wheels. They carry the entire weight of the train, but that's only the beginning. A second set of wheels presses against the sides of the rail. These are guide wheels. They stop the train from moving left or right, keeping it perfectly aligned, even through sharp turns. Then comes the secret most people never see. A third set of wheels sits underneath the track. These are called upstop wheels. Their job is incredibly important. They clamp the train to the rail, preventing it from lifting off even when passengers are completely upside down. So, when the coaster enters a loop or races over a steep hill, the train isn't balancing on the track, it's actually locked around it. The rails hold the train, the guide wheels keep it centered, and the upstop wheels prevent any possibility of flying off. Together, these 3 wheel systems create a secure connection strong enough to withstand enormous forces. Because engineers never rely on gravity alone, they make sure the train stays attached to the track every second of the ride. Now comes the biggest mystery. How can a roller coaster turn completely upside down without anyone falling out? The answer isn't magic, it's physics. Before the train reaches a loop, it has already built up a huge amount of speed. As it enters the loop, the train wants to keep moving forward. At the same time, the curved track pushes the train toward the center of the loop. This creates a powerful force known as centripetal force. That force keeps the train following a circular path even when completely upside down. But engineers don't stop there. The shape of the loop is carefully designed. Early roller coasters used perfect circles that created violent forces on passengers. Modern coasters use something very different, a shape called a clothed loop. At the bottom, the curve is wide, allowing a smooth transition at high speed. Near the top, the curve becomes tighter. Because the train is already moving slower, this reduces the pressure on passengers, making the ride safer, smoother, and far more comfortable. Every loop, every twist, every turn is calculated by powerful computers down to the smallest detail. Because engineers don't just build exciting rides, they design precise paths that keep the train safely attached to the track from beginning to end. Here's something that surprises almost everyone. Most roller coasters don't use powerful engines to complete the ride. In fact, the engine only has one job: to pull the train to the top of the first hill. This happens using a chain lift, or on newer rides, a powerful magnetic launch system. Once the train reaches the top, something incredible takes over gravity at the highest point. The train stores potential energy as it begins to fall. That stored energy changes into kinetic energy. In simple words, height comes speed. The farther the train falls, the faster it travels. That speed carries it through loops, sharp turns, twists, and giant hills without needing an engine to push it. But here's a clever part: engineers carefully calculate every hill along the track. You'll notice the first hill is always the tallest. Every hill after that is slightly lower. Why? Because friction, air resistance, and wheel contact steal a little energy every second. If the next hill were taller than the first, the train would slow down and stop. That's why every meter of the track is precisely designed to make sure the train always has enough speed to finish the entire ride. Even if the electrical power suddenly disappears, the coaster can usually complete the course using nothing but gravity and momentum. No engine, no acceleration, just brilliant engineering and the laws of physics working together. After all the speed, the twists, and the giant drops, one final question remains: how does the train stop without crashing into the station? The answer is one of the smartest safety systems on the entire ride. Most people think the brakes grip the wheels, but modern roller coasters usually don't touch the wheels at all. Instead, they use magnetic brakes. Powerful magnets are installed along the track as the train passes between them. Metal fins attached under the train move through a magnetic field. No contact, no friction, no sparks. Yet the train begins to slow down. How? Because moving metal through a magnetic field creates electrical currents. These currents produce an opposing force that naturally resists the train's motion. The faster the train moves, the stronger the braking force becomes. As the train slows down, the braking force gradually decreases, creating an incredibly smooth and controlled stop. There's another huge advantage: magnetic brakes don't rely on electricity to stop the train. Even if the power suddenly fails, the magnets continue working automatically, making them one of the safest braking systems ever designed. Additional safety brakes are placed at different points along the track just in case the train needs to stop earlier or another train hasn't yet left the station. Every movement is monitored by computers, sensors, and automatic control systems, because engineers know the ride isn't over until every passenger has stopped safely. Every year, millions of people ride roller coasters. They travel at incredible speeds, experience extreme forces, and turn completely upside down. Yet serious accidents are extremely rare. Why? Because the ride is inspected long before the first passenger arrives. Every morning, engineers walk the entire track looking for the smallest signs of damage. They inspect the rails, the wheels, the bolts, the restraints, and every critical component. Nothing is left to chance. Many parks also send an empty train around the track before opening. Sensors monitor every movement, every vibration, every wheel. If something doesn't match the expected values, the ride doesn't open. Throughout the day, powerful computers monitor the coaster, tracking its position, its speed, and the distance between trains. The track is divided into safety zones known as block sections. Only one train is allowed inside each section at a time. If the next section isn't completely clear, the following train automatically stops, preventing any possibility of a collision. Every restraint is also checked before departure. If even one safety bar isn't fully locked, the train simply won't move. The ride operator cannot override these protections, because modern roller coasters are designed to stop the ride before anything becomes dangerous. Behind every exciting ride are thousands of engineering calculations, daily inspections, automatic monitoring, and multiple independent safety systems working together every single day. So while roller coasters may look terrifying to riders, to engineers, they are among the most carefully tested and monitored machines in the world. So how do roller coasters never fly off the track? The answer isn't luck, it's engineering. 3 different wheel systems grip the track from every direction, keeping the train locked in place even when completely upside-down. Gravity provides the energy. Carefully designed tracks control the speed. Modern loops reduce the forces on passengers. Magnetic brakes bring the train to a smooth and safe stop. Powerful computers continuously monitor every train, every wheel, every sensor, every second. If anything looks unusual, the ride automatically stops before a problem can become a danger. Every morning, engineers inspect the track, every bolt, every wheel, every restraint, because excitement should never come at the cost of safety. That's why behind every scream, every laugh, and every heart-pounding drop are thousands of hours of engineering, testing, simulation, and precision. The next time you ride a roller coaster, remember this: you're not trusting luck, you're trusting one of the most carefully engineered machines ever built, designed to deliver maximum excitement with extraordinary safety. If you enjoyed this documentary, don't forget to like, share, and subscribe to RailForge, because here we explore the incredible engineering behind mega structures, modern technology, and the machines that make the impossible possible. Thanks for watching, and we'll see you in the next documentary.